Hello, and thank you for joining the webinar today. We're going to give folks another moment or two to log in, and we'll be starting soon. Okay, let's get started. Hello, everybody, and welcome to today's Better Buildings and Better Plants webinar, dedicated to bringing you the latest actionable insights from leading industry experts. Better Buildings and Better Plants webinars are a chance to explore topics, technologies, and trends that affect your organization. Next slide, please. Today's webinar is called Pushing the Envelope, Coupling HVAC Upgrades with High-Performance Building Envelopes. Before we dive in, there are a few housekeeping points I would like to cover. Please note, today's webinar will be recorded and archived on the Better Buildings and Better Plants Solution Center. We will follow up when today's recordings and slides are made available. Next, attendees are in listen-only mode, meaning your microphones are muted. If you experience any audio or visual issues throughout the webinar, please send a message in the Q&A box located on the bottom of your Zoom panel, and our tech support team will be in touch. Next slide, please. My name is Ben Mitchell, and I'm your moderator. I'm a Science, Technology, and Policy Fellow at the Department of Energy, supporting the Better Buildings and Better Plants initiative. Next slide, please. And so just to quickly go over what we'll be talking about today, or our agenda for the day, we're going to start with some welcome and polls. And then we have two great presentations, which we'll get into soon. And then we will wrap up with Q&A at the end. Okay, next slide, please. Today, we will be using an interactive platform for Q&A and polling. So if you could please go to www.slido.com on your mobile device, or by opening a new window in your internet browser. Today's event code is DOE. If you'd like to ask our panelists questions, please submit them anytime throughout the presentation. We will be answering your questions near the end of the webinar. You can select the thumbs up icon for questions that you like, which will result in the most popular questions moving to the top of the queue. Okay, let's go over to the next slide. Awesome. So we want to learn more about you. So let's start off with a few polls. So if you could join us over on Slido and respond to the following questions. If you're having any issues, please message our tech support by using the Zoom Q&A function. And so what sector best describes your organization? It looks like we have a lot of contractors or consultants, a lot of folks from local gov, state government, public sector being represented strongly, utilities, higher education, multifamily, great. And we can go on to the next question. So another chance to learn a little bit more about the attendees today. So what is your role within your organization? Got some folks typing: architect, energy managers, engineers, amazing energy engineers, project managers. I'm seeing sales, analyst. Great. So it looks like we have a really good distribution of folks today from a lot of sectors with a lot of different backgrounds and experiences. Awesome. Okay, and then the next question. So this is just for us to gauge a little bit about your experience with envelope upgrades. And so has your organization considered envelope upgrades? And so you can say, yes, we've considered and done them, we've considered them, or no, we haven't considered them, and then no, we haven't considered them, but we would like to. So it looks like a lot of folks have done envelope upgrades. That's great to see. A lot of folks considering them, but not executing. So that'll be interesting. And hopefully this webinar will be able to help build that case for you. Okay, some folks that haven't considered but would like to. This is good. Awesome. And then the last question we have here is just to kind of gauge what some of the challenges you might have, or some of the barriers that you're facing. So what are your biggest challenges to implementing envelope upgrades? So if you have or even haven't implemented, what have been your challenges? Yep, cost, we've heard that, yes. Okay. M&B, interesting. Okay. Staffing and funding. Wow, a lot of good insight here. Cost, funding. Okay. I think we're starting to notice a theme here. Monies. Okay. I think we have a little bit of a theme, and I'm excited to move on to our presentations, and hopefully they can talk a little bit about how they can build the business case here to make these more cost effective. So today's presenters, we have three great presenters. So Barry Abramson, Robert Hart, Barry Abramson from Servidyne, Robert Hart from Lawrence Berkeley National Lab, and Dr. Bess Kriedemeyer from Syracuse University. And so can we go to the next slide? And I can introduce Barry and Robert. So Barry Abramson is a principal at Servidyne in Atlanta, Georgia. And he will be co-presenting with Robert Hart, who is a researcher at Lawrence Berkeley National Lab in the Windows and Envelope Materials Group. And with that, I'm going to hand it off to Barry and Robert to kick us off with the first presentation.
Awesome. Thanks, Ben. So yeah, I'm going to start it off. I'm going to kind of give a little bit of overview of Windows and why they're important, and then hand it off to Barry to talk about some applications, some real-world examples of these kind of retrofits happening in the field. So next one, please. So yeah, the idea here is to kind of reframe your thinking about window upgrades. We saw, I think, an overwhelming response that cost is an issue. And so want to think a little bit about, maybe give some ideas on why we think cost is an issue and maybe some approaches that we could do to change that theme. Next slide, please. So first, just, setting the stage here, why do we care? We care because windows are typically the kind of lowest thermally performing part of the building envelope. So on a typical commercial building, windows are about 12% of the envelope area, but account for about half of the heat lost through that envelope. This is on meeting the codes of today. As we go to older and older buildings, it stays pretty consistent. The insulation in the walls gets worse, and the windows typically get worse as well. But that's something you can see here on the right. We can change that. A higher performance window, you can make a big difference in that heat loss fraction. Next slide, please. And so one way I think is a nice way to think about this, about why we should care, and this gets maybe to that cost issue a little bit as well, is this great slide that put together years ago by Chris Mackey at Payette Architects is, if this was well insulated, right? This kind of fully glazed facade, and we had an incremental cost of, say, $10 a square foot, going from the double to a triple pane. You wouldn't need this very expensive, $50 to $100 a square foot perimeter heating system that was installed, right? So you kind of reframe that thinking of, hey, we need to do HVAC first. We need to have this perimeter heating. But think about that as an envelope first approach. You could actually save money by putting in a higher performance envelope. And so that's kind of the theme of kind of reframing that thinking. Next slide, please. Of course, energy, we know is kind of not the most common reason people could put in a higher performance envelope or do an envelope upgrade, period. It's usually for some other reason, particularly on a retrofit, it's because you're having a problem, right? Maybe you have uncomfortable floor area near the perimeter. You have kind of unusable area because occupants complain of draft or overheating or glare or something like that. That really kind of eliminates that area as a usable space, and you'll see walkways and things like that instead of having desks there where people get the nice view. Higher performance windows can eliminate that, right? You can really gain back that square footage. Of course, health, right? Especially if you have single pane windows, condensation buildup in colder climates can be a real problem. And for the occupants, and going to a higher performance product eliminates that. And as well, UV damage and things like that, where again, with older single pane windows, would have quite a bit of UV penetration and degradation of materials on the other side of that. Okay, next slide. Uh, so just to kind of get an understanding of how big this market is, I thought I'd throw this slide in here. So our commercial window market is about 98 billion square feet in the US. About 2.4 million single pane commercial buildings are still out there. Windows right now are retrofitted at about 140 or so square feet of Windows retrofit per year, and 284 million of new construction windows going in per year. Uh, it's a lot of numbers there, but if we do the math on this about the retrofit rate and the amount of windows that are out there, turns out it's about a 2% per year retrofit rate for the single pane windows. And of course, that means, at that rate, we're never going to replace all the single pane windows that are out there. And we really need to find a ways to accelerate that adoption. And next slide, please. Uh, so with that in mind, we've been working the last couple years on trying to understand the market and some of these barriers to high performance window adoption and window retrofits in general. And so this is some work by FTI last year, or Facade Tectonics Institute, for those that don't know them. That really talk to industry to get an understanding of what are the kind of biggest barriers of making changes or doing high performance Windows adoption. And so a few of these just to highlight here, right? So the cost increased over business as usual, right? I think most people noted that in the survey. Insufficient return on investment on that first cost, perceived risks, right? Anytime you do something new, there's that risk is a cost, essentially, because you don't know, or the contractor doesn't know exactly, they're not familiar with the new products. Uh, the projects are HVAC driven, right? I mentioned that at the beginning, right? You kind of doing the HVAC first approach and then thinking about what you do to handle that HVAC as a kind of as opposed to doing it the opposite. Code compliance is lax. And in kind of the last one here is this kind of insufficient capacity or resources to design better facades. And that's one where the consultants and the others, or the access of building owners and building managers to knowledgeable consultants out there that have experience in implementing these higher performance facades is lacking in the market. Next, please. And so along with that kind of here, barriers is here, what are some kind of, what's a blueprint to change that, right? Here's kind of 10 major ones highlighted. I won't go through them all for time, but kind of highlight a couple of them here. So, if this first one, this kind of concept one is developing an above code certification program for high performance facades. So this is something, on the residential side, which has been extremely well received, right, with something like Energy Star, kind of Windows specific program. On the commercial side, there isn't really an exact corollary. There's things like LEED and others that are kind of whole building, but nothing specific for Windows. So there's no necessarily that added value or recognition for doing a product that's higher performance. And so this is something that we're working on, is developing a program around this. And so we're talking to industry, talking to owners and others and consultants about what would need to be included in a program that's like this. And then the second one I'll mention here is kind of really just access. So this is creating tools or programs that communicate the benefits of higher performance facades, right? So if you can't assess the benefits, how are you going to end up using them at all? If we can go to the next slide, please. Uh, and so what we've been working on kind of a few different ways of trying to access that and try to understand, what tools is the market using and how can we make changes in those tools. You see a great little pun by Jamie here about, trying to make your window evaluations not such a pain anymore. And so, if you go to the next slide. So some of the progress we made in the last years or so is just getting some, beyond just a retrofit window, right? Kind of window replacement. There's a lot of other things you can do. Secondary windows, different shading systems, window films. There's a lot of other technologies to do than say just that maybe high cost full window replacement. And we're trying to make sure that these other solutions are out there for that in areas where people are looking, right? So we've kind of worked on updating the ASHRAE guides to include these measures. The Better tool, ComFen, which is a good early analysis tool of looking at energy performance, getting these measures into building sync, and then eventually audit template as well for folks that are doing that. And then also anyone who's working in the federal area for feds in getting those different options in there as well. And then finally, if you go last slide here, uh, one I just wanted to mention slash plug is a new tool that we came out with last year. So this is a spreadsheet-based tool, so made to be very easy to use for early analysis on commercial secondary windows. So it's a first step kind of Windows savings calculator. So just for you to get a really kind of, again, first pass of would secondary windows make sense for your existing building? We have, offices, hotels, schools, hospital, multifamily, all in the tool. It's Energy Plus based. It gives a nice, again, kind of quick analysis to say, yeah, are we in the right ballpark? Might this be something we want to investigate? And then you can go, take the next step. So that tool is available now. We put a QR code on there. Please check it out. And I think I'll hand it off to Barry now. Thank you.
Great. Thanks, Robert. So it was that slide you had on the number of buildings with single pane windows and the percentage that are getting retrofit every year was really a great framework for me to see because, I've been more on the ground trying to deal with this on a building by building basis. And it's nice to kind of pull the lens back and see what's happening overall and how what we might be doing at this building or that building kind of fits into the big picture. So I appreciate that. Also, I'm glad to see that when the poll went out as to who's in the audience, there were a lot of engineers out there. So my slides are going to go through a few examples that I call back of the envelope and the engineer's window view. And if you go to the next slide, I'm going to talk about three different buildings that we've worked on, very different between each other and different eras. And the interesting thing is that we've worked with these buildings for about 15 years, starting doing energy audits around 2010. And then we've done ongoing consulting work for each of them over the years. And it's been an evolution. And I think this kind of tracks what Robert was going through in terms of looking at the barriers and trying to make our way through those barriers in different ways over the years. But I would say that the first energy audits we did at all three of these buildings, we didn't really pay much attention to the envelope beyond window film, just sort of, low cost, relatively good payback. If anybody had brought up putting in secondary windows or anything more elaborate back in 2010 when we were first doing the audits, we would have said that's ridiculous. It's not even worth a back of the envelope calculation. And then about maybe 7 or 8 years ago, we started doing a back of the envelope calculation because the secondary windows were starting to come, into play, and saw that they were 30 or 40-year payback. So back of the envelope is pretty much where we stopped. And then it's only been in the last few years where we've really started to seriously take a look and actually have projects move forward. And all three of these buildings are moving forward with installations of secondary windows. So I want to talk about each one of those and kind of what the motivations were and some of the impact that's driving these projects. So go to the next slide. So first building, 1967. This is a classic. It's got an interesting exterior structural design. 600,000 square feet. It's 25 stories. Multi-tenant office building. Kind of typical HVAC configuration for its vintage, which was natural gas boilers, electric centrifugal chillers, and large air handling units. The interior systems, VAV reheat. They weren't originally VAV, they were constant volume, but they've been converted over the years. And the perimeter constant volume induction units below the windows. And the envelope single pane windows. So next slide. One envelope thing we did notice when we did the first energy audit back around 2010 was above the vision glazing was spandrel glass. You can see on the left, right above the vision glazing, there's the spandrel section, which is normally above the ceiling, and all that was there was a single pane of glass, just like the vision windows. It has some, I think, overspray of some of the fire protection on that particular picture, but it's basically just a sheet of single pane glass. And so we did actually recommend dealing with that. It was a no-brainer, and you can see on the right that the solution being insulating that section all throughout the building, which has taken a number of years to do because it's pretty invasive and you really have to do it when the tenants turn over. But that part of the envelope upgrade was early on identified in a kind of straightforward project. Next slide, please. The aspect of dealing with the vision glazing more came into play, as I said, a few years ago. And we're looking at secondary windows because of an HVAC modernization plan. Also, if you see those perimeter induction units are on the floor, and like that image that Robert showed, that we could get rid of the perimeter heating system if we had better envelope. That's exactly the case here, where the calculations were done with heat load savings, and we can actually get rid of that perimeter induction system with the perimeter heat once a good secondary window system is put in place. So that frees up floor space, which is probably trumps any economic aspect of this whole project. But also another benefit was thermal comfort. There's a lot of challenges in this building because of solar load and the varying facades. So that was a big consideration as well. Next slide. So let's look at what happened. So here you can see some pictures in action. The one on the left in progress. On the right is a picture of this an office where secondary windows were installed. The perimeter induction units are gone. And if you look at the comparison of thermal performance, the retrofit brought the U value down from a little over 1.1 BTUs per square foot down to 0.28. And solar heat gain coefficient also was reduced pretty substantially as well. So a very, very dramatic impact on the loads. Next slide. So we're looking at those load reductions. This is a calculation that was done to figure out, where's the heat going in the building, everywhere from the ventilation load to reheat, warm up. But as you can see, the per floor dominant loss is through the windows, and the calculation of heat load with the secondary windows was about 5,400 MVH. And you can see the kind of the evolution over time for this building. Existing boiler plant, which was designed in 1967, 20,000 kBTUH. The heating load without the window retrofit, 8,500, and then with the window retrofit, with the secondary windows, 5,400. So very, very dramatic decrease with a commensurate dramatic decrease in the capacity of the heating system when that heating system needs to be replaced, which is currently on the table because of the modernization program in place at this point. Next slide. Okay, I'm going to go more quickly through these next buildings. The next one, interesting property built in 1925 originally, was renovated in 1990, 7-story, 700,000 square feet. Kind of typical HVAC. And the interesting thing here is that originally it was all single pane, both the 1925 and 1990 wings. But the 1925 wing had a secondary window retrofit that was done, and you can go to the next slide. Not so much because of energy, but because of noise and thermal comfort. This property is in the heart of downtown San Francisco. There was very high-end tenant on the lower levels of the building and a lot of noise from the street. Also, there was a lot of leakage through the glass. So it wasn't just thermal, there was infiltration as well. And then on top of that, there's an aging boiler plant. So there's an added benefit of reducing the thermal load. Next slide. Just to look at the economics. So we were looking at this building at replacing the boiler plant with heat pumps. And if we looked at doing the envelope, a secondary window retrofit, cost a price tag about 1.6 million. And then you add the heat pumps that would be needed for that load, another 2.8 million. So we have a total project cost of 4.4 million. If we didn't do the envelope and we just had heat pumps with the heating load, the increased heating load, it was about a 33% increased load and a 3.4 million price tag for heat pumps alone. So you can see that this sort of trade-off, for $1 million extra bucks, we get the 1.6 million envelope upgrade. We do need to spend more money, but then we've got ongoing operating cost savings and comfort savings going forward. Okay, next slide. Last building, 2000, vintage, smaller footprint, but still pretty tall building. Again, very typical HVAC systems for its age. What's maybe a little unusual is a building that, not that old. Well, I guess it's pretty old, but single pane windows here as well. Next slide. In this case, there was a few other considerations. The existing windows being single pane, I had to have safety bars. You can see that in that image, which also made it a bit challenging to figure out how to get secondary windows in there. But another couple of considerations were a very limited roof area for, again, looking at replacing a boiler plant with heat pumps. But then another consideration is that this building is right along the lines of the city of San Francisco's district steam system. And so there's an opportunity to hook up to that steam and get rid of the boiler plant entirely. However, the district steam cost was quite high compared to gas. And so anything we could do to reduce the heat load would have a multiplier effect in terms of ongoing operating costs. So those were some of the driving factors at this third building. And next slide. Okay, so just to bring it to a close, again, we had 3 buildings, different vintages, very different motivations at each one, and all of which, when we started working with them, we didn't even have a clue or a concept as to really looking at the kinds of significant envelope upgrades that would eventually be part of all of these buildings' evolution through today. All of them have begun installation of the secondary windows, some more than others, but all have a multi-year capital plan to get through the entire building with those secondary windows. And last slide. Just want to thank you and give a quick shout out. So all of this work was a collaboration between Taylor Engineers and Servidyne. And so wanted to give a shout out to Laura Van Rienema, who did part of this presentation and also part of the engineering work. Thanks. Hand it over to Bess.
I will jump in quick and introduce Bess. Thank you so much, Robert and Barry. A quick reminder to the audience that to send all of your questions to Slido. So www.slido.com with the event code DOE. We look forward to answering your questions at the end of the session. And now I'm going to pass it over to Bess. So Bess Kriedemeyer, or Dr. Kriedemeyer, is an associate professor at the School of Architecture at Syracuse University. Bess, go ahead and take it away. Thank you.
Thank you, Ben. And thanks for everyone for joining today. So as Ben mentioned, I am with Syracuse University. I'm in the School of Architecture, where I'm a faculty member there. And really excited to be part of this. I'm going to kind of zoom out and present a project that does include window upgrades, but also talks about a whole building retrofit package. So the title of this presentation is The Envelope Please: Unpacking Innovations in Whole Building Retrofit Design. Next, please. So this project is sponsored by the Department of Energy with support from the New York State Energy Research and Development Authority, or NYSERDA. It's part of the Advanced Building Construction, or ABC initiative, which promotes energy efficient solutions for new buildings and retrofits. This is a long project, so it's almost a 6-year project, and we are in the final 6 months of the post-retrofit monitoring phase. The project is led by Syracuse in collaboration with TK Fabricate, Tatum Engineering, Cycle Architecture, Signatron, and VIP Structures. So we've got a pretty incredible, very big, very talented team. Next, please. So as a lot of us are aware, kind of zooming back out to this retrofit challenge, we face the challenge of needing to retrofit about 90% of our existing residential buildings. And roughly 60% of those will require a whole building retrofit, including envelope upgrades, to meet our kind of efficiency goals. Next. And at the same time, we're faced with exactly how to do this. So we know that deep energy retrofits are very complex. They are very costly. They can be very disruptive, and they are highly labor intensive. So we've got multiple trades involved, multiple visits to the site. And this part is key. They don't yet provide solutions to really coordinate envelope and mechanical upgrades. Next, please. So our goal for this demonstration project is to develop and demonstrate an integrated whole building retrofit approach that gets us 75% thermal energy savings, significantly improves comfort and indoor air quality, minimizes disruption to occupants, and is cost effective. So our initial application for this approach is for single-family attached homes in cold climates. And we envision this approach could scale to low-rise multifamily and possibly even single-family homes. Next, please. So some key elements of the approach have included, first, coordinated systems. So for retrofits in cold climates, to maximize thermal energy savings, they must integrate highly insulated, tight building envelopes with compatible HVAC systems to capture those energy and installation and maintenance efficiencies, while also emphasizing thermal comfort. Next is designed from the outside in. So to reduce cost and disruption, we really try to limit interior work as much as possible. The next one is integrated design delivery. So this involves tight coordination and collaboration across all teams and trades, really at all stages of the process. And this is one of the biggest lessons learned for us from this project so far. Next. So our demonstration site is located on Syracuse University's campus, where we retrofitted 2 student apartment buildings in the summer of 2024. So over a year ago now at this point. They're student apartments, kind of dormitories built in 1972. Each building has 8 2-bedroom units, so 2-story units each. The buildings are nearly identical in layout and in orientation, which we're finding is making for some pretty valuable pre and post retrofit evaluation. For us, these buildings represent the single-family attached type, and I will say they are deceptively simple in geometry. So even though we see a fairly straightforward kind of rectangular bar building type, that's a basic extrusion, there are details and kind of material shifts in the wall assemblies and proximity of the window to the roof. These all made for some kind of unexpectedly challenging details to work through. We do have 2 types of wall construction. We've got precast concrete walls and wood frame walls. for a total effective R value of about 5.3 for that existing building. Buildings had electric resistance baseboard heating and no mechanical cooling or ventilation. So these tend to be stuffy, uncomfortable apartments. And you can see from the map, we've got a lot of them in this area. Next, please. So our retrofit approach integrates innovations in scanning, the envelope, and mechanical systems. And designing the retrofit is based on first capturing accurate 3D building information for configuration and fabrication. Second, reducing the space heating and cooling loads through a highly insulated envelope. And third, meeting those reduced demands with a novel, highly efficient mechanical pod solution. And I'll talk a little bit about each of those very briefly. Next, please. So the 3D scanning and modeling workflow is developed by our partners at Signatron. It captures 3-point cloud information that produces a wireframe model and deviation maps, as well as tools like an automated panel layout tool. And essential here is the ability to understand the imperfections along the facade and incorporating that information into panel fabrication, into the attachment logistics, and ideally into that whole installation process. Next. Our insulated envelope uses essentially the Federlite panel system. So it's a prefabricated R27 EPS foam panel. The thickness in our approach varies according to those different wall assemblies. So we've got a panel thickness ranging from 6 inches to 7.5 inches. The exterior surface of the panel acts as the barrier system here, which means that the seams, the panel-to-panel seams, are pretty critical for maintaining that continuous seal. You can see in the photo how the panel attaches to the precast concrete end wall in this condition, where we've got a wood ledger and vertical hat channels, which are also embedded into the panel. So those hat channels are adhered together as opposed to mechanically fastened. Next. We installed triple pane windows on the second floor bedrooms. We replaced the rear glass doors with a high performance door and side light. And then a few months ago, we actually replaced the front doors on one of the buildings and are now in the process of studying the impacts of that. Next, please. So the high efficiency mechanical pod is one of the most kind of novel technologies or aspects of this whole building approach. It's developed by TK Fabricate. And each apartment building, in our case, has 4 pods, and each pod services 2 units each. You can kind of see in these diagrams, the pods are sitting outside on the front of the building, so kind of 4 in a row. The pods deliver all conditioning needs for the apartment, including heating, cooling, fresh air ventilation, and hot water. The pod itself comprises a modular kind of kit of components and is sized based on those reduced envelope loads. So here's where we're seeing that kind of tight integration in terms of the design and sort of optimization of that pod system. These systems run on electricity, so we've got cold climate heat pumps in the pod, which deliver heating, cooling, and hot water through these insulated mechanical chases that run up the front of the building and then over the top of the roof. And then they penetrate the building at that roof. And again, you can sort of see in the diagram where those chases kind of move up and wrap around the building. They penetrate the 2 bedrooms and the second floor and attach to fan coil units, new fan coil units in both bedrooms and then the living room on the first floor. The ventilation system is exhausting the stale air and bringing in fresh, continuously filtered outdoor air continuously, so all times. Again, this is something the buildings did not have before. And then the pod's location, being on the exterior of the building, allows for really easy access. It features a real-time performance monitoring system, which provides regular maintenance or alert notifications. Next, please. So I mentioned this is basically a 6-year project with many stages. We monitored the pre-retrofit conditions for 1 year. We retrofitted the buildings during the summer 2024, and now we are in that post-retrofit monitoring stage. The project officially concludes this coming June, so we are collecting as much data as possible until then. Next, please. Our monitoring scope, just to kind of touch on this, it's quite comprehensive and includes measuring whole building energy use, interior air quality, building envelope insulation and air tightness. We're also capturing some occupancy information through motion sensors at the front doors, and we've got some window and door contact sensors in a couple of the apartments. We've also been conducting pre and post retrofit surveys with the student residents, which has been really provided a lot of insights into the comfort. Next, please. Like all projects of this scope and scale, we've had a lot of constraints that informed a highly iterative design process. So again, like many projects, we had a tight budget that for this one, it was put together at the time of the proposal, which was a while back. We had a fixed construction window and needed to complete the installation for both buildings in less than 3 months while students were away for the summer. We knew that these buildings contained asbestos and wanted to minimize the number of penetrations, so that was a big driver for some of our design iterations. We also knew we wanted to allow for easy maintenance and minimal occupant disruption post-retrofit, so that became another factor informing the design. Next, please. Just a bit about budget. This was probably the most challenging aspect of the project. So the original budget was put together in 2021 and construction took place in 2024. So pretty good amount of time between kind of that original cost estimating and the actual implementation. Our proposed budget was capped at under $3 million, again, for both buildings. And I also want to note that this included costs for manufacturing the pod system for the very first time at this scale. Next, please. Our initial bids came in significantly high, almost at 4.5 million, which led to a very rigorous value engineering process that took us over 3 months, which is about 2 months longer than what was built into our original schedule. Next, please. We developed 6 value engineered scopes and priced them with our partners at VIP Structures. We modeled the energy savings kind of along the way and really, had lots of collaborative meetings deciding how best to proceed and still meet the project goals. In the end, we were able to arrive at a VE scope that met the budget and included the full retrofit package for both buildings. It did require us to switch panel providers and barrier strategies, but we gained greater cost savings, faster delivery, and we were still able to hit our energy savings targets. Next. And our actual costs are also within our original budget. So we're very proud of this effort considering all of these challenges. I know there were a lot of kind of comments about costs up front. Next, please. Because we kind of underwent such a rigorous value engineering process, we have fairly detailed cost breakdowns from the bidding, from this process for several different iterations. So we're really able to understand what led to the high bids in the first place and what areas made a big difference in cost. Go to the next slide, please. And some of these areas included like the roof system, the panel system. We were really all across the board, we had to really shave off the costs, and we found some different innovative ways we did that, which maybe we can cover in some of the Q&A. Next, please. So I'm going to move kind of quickly through some of these photos. These are just some of the highlights of the construction process. Here we're seeing the foundation panels going in and a mock-up for the corner condition. Next. We were able to fabricate large panels, making for faster installation and fewer seams. Next, please. Here we're seeing some preparations for the mechanical pod placement. We've got some new sidewalks that we put in. And then on the right, we can see those roof chases for the mechanical runs. And this area actually took us a lot longer in terms of the installation a lot longer than expected because this was one of those areas in the retrofit where multiple trades intersected with each other. So we've got the roofers, HVAC, plumbing contractors, GC, requiring a lot of coordination up here. It was hot, like end of July, and we were really figuring out how to run these things for the first time. So it was a pretty challenging area of the retrofit. Next, please. The pods were placed near the end of our schedule. The last panel was put into place and the chases closed up with insulating panels. And all of this was incredibly tight in terms of our timeline. You know, at some points towards the end of this summer, we had to have some difficult conversations and talked about if we would need to relocate some of the student residents for a few weeks or even a whole semester, since our schedule did extend a little longer than expected. Next, but we still managed to finish in time. So here we're looking at a photo of the backs of the buildings. You can see some of those rear doors, second floor windows. You can see the roof hatches up top. And then on the left side of the photograph you can catch some of those building envelope sensor boxes, which were installed on one of the buildings. Next, please. Residents moved in that August and were able to take advantage of some of the cooling that was provided, which none of these apartments in the areas really have. So we got some cooling degree days captured before heading into the long Syracuse winter. Next, please. So here we are in heating mode, and student surveys throughout the last year plus have really provided some great insights into the comfort of the buildings, particularly how much more consistent the temperatures are feeling as compared to those pre-retrofit conditions, both for hot and cold months. And we really feel this is in large part due to those envelope upgrades. Next, please. Our monitoring to date is showing that we're hitting the 75% thermal energy savings for the heating season. And these charts are showing energy use trends relative to outdoor temperature for those colder months, so between October through March. Next, please. Overall, we're really proud of this effort. Our team has done a tremendous job. We are meeting our retrofit goals in a lot of ways. So we're seeing that 75% thermal energy savings during the heating season, also providing that continuous ventilation, which is new. We're seeing 20 to 30% reductions in the average CO2, with over 90% of the time the air is in the safe range for particulate matter. In terms of timeline, our construction timeline was incredibly fast at about 2.5 months, when projects like this can take up to 1 or 2 years to complete. And we're seeing some significant savings in terms of operational costs, showing $6,500 per building, again, including improvements in air quality and cooling and things like that. And in terms of scaling, we do view this integrated panel to pod strategy as something that can scale with different kinds of distribution schemes and ways that we might wrap the building with the mechanical chases, for example. Next, please. So we're still analyzing the results, we're collecting data, but we're really starting to see how the envelope is an enabling system for whole building retrofits. So in looking at the energy savings breakdown, our analysis is showing that the wall and foundation panels contribute over 1/3 to that 75% thermal energy savings goal at about 1/8 the cost. And when sized based on those loads reduced by the envelope, the mechanical pods are contributing, again, like over 1/3 to the energy savings while adding cooling and ventilation. So we're really excited about how these systems are working together and the roles that enclosure is playing. Next, please. So to kind of wrap up on a few lessons learned through this project specifically, envelopes matter. So reduced loads from the envelope led to optimally sized mechanical pod systems, making that 75% energy savings possible while improving comfort. Next is that whole building retrofits require time and budget for research, design, and iteration, especially for meeting this really fast installation schedule. We've learned through this project especially it's important to strive for continuous processes and workflows that promote that integrated design, integrated project delivery. Part of this involves identifying schedule constraints, really considering that value engineering process as key to the entire design process, and monitoring the budget through all stages is super important. Socializing the project early was really helpful in terms of permitting for us. We had a pretty seamless process for that. And then maybe one of the biggest takeaways as well is engaging contractors and subs early and often so that we can be really clear in terms of what the project goals are, what are the individual scopes and responsibilities for each team member and contractor, and really making sure they're aware of how they are contributing to the success of the project and how we can plan for assumed risk. So again, we have this new mechanical pod system, for example, or new ways that we're distributing the mechanicals and intersecting with the envelope. So being really clear in terms of how that's working helps to eliminate that assumed risk and also plan for better operation and maintenance in the end. And that's it. Thank you very much. I'll pass it back to you, Ben.
Thank you so much, Bess. Thank you to all of our presenters. We're going to move into the Q&A portion of this. So I invite all of the panelists to go on camera, please. And remember, if you haven't already for the Q&A session, please join us over at Slido where you can submit questions and upvote questions. It is www.slido.com. DOE is the event code. We've got lots of great questions. I think we have time for a few of them. I'm going to start with Robert. So one of the questions here is, do secondary windows mean fully replacing the existing single pane with double pane windows, or does it mean adding a second glazing layer to the existing single pane?
Yeah, secondary glaze, you leave the kind of original window in place, and then you add on a second window. And there's a lot of different ways to do that. Interior or exterior products, you can put it kind of within the frame or exterior to the frame, kind of surface mounted. But yeah, none of them involve kind of removing the existing. And just maybe even further on that, if you have operable windows, there are operable products out there that can accommodate that. So there's a really wide range of the secondary products.
Awesome, thank you. And then we'll go to Barry. So one of the questions here that's gotten upvoted a lot is, the 1967 building may have been constructed with lead-based paint, asbestos, and maintained with PCB-laden window sealants. How are you accounting for these common contaminants in terms of ROI and specifically as it relates to lost revenues due to unoccupied workspaces?
So that's a great question. Asbestos check is all over the place. And so there's been a multi-year program to abate the asbestos, and that's tracked as floors are turned over. So that's one of the reasons why, for instance, the insulation behind the spandrel glass couldn't be done in one fell swoop, even though it would somewhat intrusive to occupied floors. It could have been done, except for the asbestos abatement. So it really had to go in conjunction with that schedule. But that abatement project, the cost of that was its own baby, so to speak.
Yeah, very interesting. And Bess, I know you mentioned in your project that there was also some asbestos in those dorms. Anything to add on that?
Yeah, I mean, it was a big factor for us. It really drove a lot of our design iterations early on to the point where we knew it would be high in cost to remediate. And just in terms of an approach that could be scaled and applied to other buildings where occupants would be in place during the installation, we wanted to minimize that interior work as much as possible. But we were counting the number of penetrations that each version of our designs would require as a way to eliminate the cost and disruption factors. So it was pretty huge, and it was something that we're really glad we did early on within that design process.
Yeah, thank you so much. Very interesting. And then I'll stick with you here, Bess. And first, I want to shout out there's a comment here in the Slido that someone in the attendance actually lived in one of those units at Syracuse University from December 1973 to 1978. And they're surprised that they've lasted that long. So the retrofit was much needed, Bess. And one of the kind of relatedly, I guess, is how did the campus community react to this project? Can you expand on the occupant surveys and did you have to get buy-in from, I guess I'm assuming your administration, but also the students as well?
Yeah, it's a great question. The university kind of as a building owner or kind of client here is an interesting one that's got its own set of challenges and like lots of approvals to kind of work through when we were finalizing the project. So that was kind of one aspect of it. I mean, incredibly supportive and excited to do this project. It's actually not the first deep energy retrofit project in the South Campus area. So there was one that was done prior to this, which also kind of generated a lot of excitement to do this and really study a slightly different approach. So the university was very supportive and excited. And in terms of how it's doing, in comfort wise for the residents, we're seeing a lot of excitement there as well. So we've had now, let's see, multiple semesters where we've had different student residents move in and out. So we're conducting surveys each time we get a new group of residents, and we're seeing pretty consistent remarks about that thermal comfort, even in hot months. So the students do move in, late in the summer, but we still hit some hot days here in Syracuse, and then it quickly shifts over to the winter mode. But that's been one of the most consistent comments is that thermal comfort, especially if students go away for a weekend or something and return, they're not faced with this kind of like icebox condition, but the building is able to kind of maintain some consistency and warm up pretty quickly. And have some more uniform temperatures, both on first and second levels, which was another big comment we found in the pre-retrofit conditions.
Awesome. Thank you so much, Bess. So we have a couple of questions on this topic here for Barry, and I'd love, Robert, if you have things to add in terms of understanding the payback periods to secondary windows. So Barry, do you have any information on the total cost of ownership or paybacks for the projects you discussed? And I guess kind of wrapping in another question there, are we seeing any subsidies for secondary window projects? And what are the sources of some of those subsidies?
Okay, great questions. So I would say payback, not. That concept, simple payback, and these kinds of, serious envelope upgrades, that's not going to be the way to justify a project. That's why I said, for years we did that and it didn't go anywhere. It wasn't until the whole equation changed with an HVAC modernization need or other benefits like, tenant complaints because of noise or thermal comfort or space, extra space opportunity by removing those perimeter induction units. All of those factors really are what drove these projects to action. It was not a simple payback because, again, it's still, even though the price of these secondary window systems has come down and energy costs have gone up, we're still talking about at least 20 or 30-year payback if you do it on the simple payback model. In terms of incentives, I know that a number of utilities incentivize secondary windows. I know in New York and some other places. Robert, I don't know if you have more on that front.
Not specifically, but yeah, there are some out there. I know there may still be some federal ones. There were some. I don't know if those are still out there, but there are state ones, utilities. Um, we've heard mixed on that, I think, is that, some people really use that as a driver, and especially municipalities, I think it really helps being able to leverage that funding to get a project started. As we've heard that multiple times, is, it kind of gives them that, even if it doesn't help, maybe solve that ROI solution, it gives them that, hey, we're kind of losing this, money if we don't take advantage. Um, but on the kind of, I guess, industry side of things, or just for normal commercial buildings, we hear kind of mixed. As some people say yes, that that's makes sense, and others say it's just so burdensome to go after that money. It's not even worth it. It's just not enough to bother with it. So I think it depends on I guess who you have doing going after that and how you can work the system. But there are certainly some opportunities out there.
Awesome. Well, thank you all so much. Thanks everyone for their questions, and thanks to our panelists for their presentations and their insightful responses. I see we're at time, but I want to quickly wrap up with just a few updates here from the Better Buildings program. So if we could go back to the slides, perfect. Thank you so much, Sam. So we have our webinar series, our winter webinar series. We have a great collection of presentations next year, so please visit the Better Buildings and Better Plants Solution Center to learn more and register for any upcoming webinars. Our next webinar is titled From the Ground Up, Geothermal Heating and Cooling Solutions. So you can join this webinar to hear how partners have unleashed Earth's thermal power to heat and cool their buildings and campuses. And finally, very excitingly, we are pleased to announce that we have dates for the 2026 Better Buildings and Better Plants Summit. The summit will be held May 11th through 13th in Arlington, Virginia. In addition to engaging in interactive sessions, attendees can look forward to plenty of opportunities to network with their fellow industry peers and experts. So please subscribe to the summit's email list at the Solution Center to hear the latest on registration, sessions, and more. And with that, I would just like to close with a huge thank you to our panelists. So thank you very much for taking the time to be with us today. Feel free to contact our presenters directly with additional questions, or if we couldn't get to your question during the Q&A period. I encourage you all to follow the Better Buildings and Better Plants initiative on LinkedIn and X for all the latest news. You can find our handles on the left half of the slide. And you will receive an email notice when today's recordings, slide, and transcript are available on the Better Buildings and Better Plants Solution Center. Thank you so much, everybody.